Alright, hey Aaron. Today was day 16 of Advent of Code. And today was an interesting puzzle again. So we had a light beam that goes through a room. The room looks something like this. We got, for example, dots representing empty space. Then we got some mirrors like this. And the mirror behaves as we expect. So if light beam comes in, for example, from the left to this mirror, it would continue downwards. And similar for the mirror in the other direction, it goes in the other direction. And finally, we got these splitters, the vertical horizontal line. So for this vertical line, for example, if the light beam goes through vertically, then it does not affect the light beam at all. It just continues. But if the light beam comes in horizontally, it will split the light beam into two light beams, and one light beam will continue upwards, and one light beam will continue downwards. And similarly for the horizontal bar. And then, so the light beam starts at the top left corner, facing right initially, and then it moves through the grid, and we're supposed to calculate how many of those positions the light beam goes through. And that would be a solution to the problem. Okay, so for this problem, we can have again a grid, and we can represent positions as tuples of two integers, x and y coordinate, and a grid will then be a dictionary from a position to a particular string. And then it will be helpful to represent the main directions using an enum. So we have north, east, south, and west. And then we also have the corresponding tuples that represent one step in this direction. And then our main function will be this function to get the new directions from a current direction and a symbol. And so for some symbols, as mentioned before, there will be two light beams coming out in different directions. So we return a list of directions and not just one direction. So we go for the symbol. If the symbol is a dot, then the direction does not change at this particular position. So we just return the current direction, and this will be in a list in order to be able to return for some symbols, return two values. So for this symbol, we just have one value, and this will be the current direction. Similarly for the mirrors, we can create a dictionary on how of the next direction based on the incoming direction. So if the incoming direction is north, then the light beam continues by going east. Similarly, if the incoming direction is east, then the light beam will continue facing north, and similar for south and west. And then again, we can use this dictionary to find the new direction, and again, there will only be a single new direction which we will return. Similarly for this character, so we have to escape in the string, but again, we can create this dictionary of values and then get the new direction based on the dictionary and return this as a single new direction. Finally, the two splitter symbols. So for example, for this symbol, we know that it does something interesting if the current direction is horizontal. So if it's either east or west, then this symbol will split the light beam in two, one of them facing north and one of them will face south. So we return this list with two elements, north and south. If otherwise, it just does not do anything to the light beam and the direction will stay the same. And a similar is true for the dash symbol. Okay, so that kind of defines the rules of the game or how the light beam moves forward. So if this, we can find the number of energized positions. So if we have a grid and a starting position and a starting direction, we'll keep track of the is energized. So this will be a dictionary that maps each position to whether it is energized. So a position is energized if a light beam passed through it at any time. Then we'll keep track of a list of active light beams. So we represent a light beam as a current time step or something like that by a tuple. So it will have a position and a direction, and then we'll have a queue of active light beams that we still need to consider. So that will be a list. And since the light beam could go around in a circle, we also need to consider, we also want to keep the previous light beams around so we can know if we already considered a particular position and a particular direction. Then we don't need to continue further off with this light beam. We kind of considered all the possibilities already. Okay, with this, we can find out the number of energized positions. So while we still get elements in the queue, we get the particular position and a direction. And then we first check if we already considered this position and direction. Then we don't need to do anything, so we just continue. Otherwise, first we have this is energized dictionary that we set it to true at the particular position. And then we'll get the new direction by getting this using this function we defined earlier. And Then we go through all the new directions. We get the new positions by adding the new direction to the current position. And then we finally check if the new position is in the grid. Then we'll need to consider the new position later at some point later on. So we add it to this active light beam list. Okay, and then with this, after a while, we should be done and have figured out all the position which the light beam goes through. So they will be set, all the position will be set to true. So in order to count the number of true elements, we can just use this sum function, and that will give us the number of true values. And yeah, that will allow us to solve the puzzle. So of course we need to read the input. We can parse it similarly as usually by going through all the lines and then enumerating through each line. And then with the function we defined above, we can solve the problem based on the initial position at 0, 0, and the initial direction will be east. All right, let's try this on the test input. That looks good. So we can also run it on the real input, and it also turns out it gives us the right solution. For part 2, it turns out it's not supposed to consider a single starting position, but we can start anywhere on the border of the input, and then always facing inwards. And we're supposed to, for each of those, we need to evaluate the energy or the number of positions the light beam passes through, and the maximum of all those numbers it will be a solution to input. So we can reuse a few things from part 1, and in particular, for the solve the problem, we first have to figure out all the possible starting configurations. So for example, we could be coming in from the top. In this case, the position, the y-coordinate will be 0, the x-coordinate will range from 0 to max x, and the direction we'll start at will be south. Similarly, we can come in from the bottom, in which case the y-coordinate will be equal to the max y-coordinate, and the direction will be north, or we can come in from the left and the right. And so we figure out all the starting positions, and then we just have this maximum number of energized positions variable, and for each possible starting configuration, we find out the number of energized positions, and then the maximum number of energized positions will just be the maximum of the previous value and the current result, and then that will be the solution to a problem. Of course, we should also run it on the test input. That looks nice, so we will also run it on the real input. All right, that's it for day 16. I hope you enjoyed today's puzzle. Best of luck in the future, and I'll see you around.